Okay, in 12b, we're going to talk about the theory of voting. So our objectives, we want to define the fairness criteria and then understand Arrow's impossibility theorem. So we'll start with the fairness criteria. These are something that you want to get written down. Criterion 1 is if a candidate receives a majority of the first place votes, that candidate should be the winner. So these all have secondary names that I'll write down next to them. This one's just called the majority criterion. All right, criterion 2. If a candidate is favored over every other candidate in pairwise races, that candidate should be declared the winner. So that one is called the Condorcet criterion. All right. Criterion 3. Suppose that candidate X is declared the winner of an election and then on a second election is held. If some voters rank X higher in the second election than in the first election, without changing the order of the candidates, then X should also win the second election. So that's called the monotonicity criterion. So that one kind of feels a little bit convoluted, but we will go over an example that explains where that could be an issue. And then the last one, criterion 4, suppose that candidate X is declared the winner of an election, and then a second election is held. If voters do not change their preferences, or one or more of the losing candidates drops out, then X should also win the second election. And that one is called the irrelevant alternatives. Criterion. All right, so now we have all the fairness criteria down. Let's kind of see what they mean by them and how they can fail. So here's an example. We're given a preference schedule for 3 candidates, and they say that the winner is chosen by plurality. Does this method satisfy the 4 fairness criteria? So if we look at what's going on by plurality, plurality is just the winner gets the most first place votes. Candidate A wins by plurality. And so what we want to do is see if this satisfies, if this outcome satisfies the 4 fairness criterion. So let's look at criterion 1. And I'll take us back to that. If a candidate receives a majority of the first place votes, that candidate should be the winner. Nobody received the majority of the votes here, so criterion 1 does not apply. So it doesn't fail criterion 1. All right, now let's take a look at criterion 2. If a candidate is favored over every other candidate in pairwise races, that candidate should be declared the winner. So if we want to check this, we're going to have to look at the pairwise comparison. All right, so we want to take a look at the pairwise comparisons of the 3 candidates. So our pairwise comparisons would be, let's start with A versus B. So remember, here we ignore C. And, whoops. In the first column, A would be the winner, because they're ranked higher than B, so A gets 5. In the second column, B would be the winner. And in the third column, B would also be the winner. So B wins, because they get those 2 votes in the last column. B wins 6-5. All right, so now let's look at A versus C. So now we ignore B. So in the first column, A gets 5. In the second column, C gets 4. And in the third column, C gets 2. So 5-6, C wins. And then let's look at, B versus C. In the first column, B wins, so they get 5. In the second column, B wins, so they get 5. And in the third column, B wins, so they get 5. So in B versus C, B wins 9-2. So in pairwise comparisons, candidate B wins both its races. So fairness criteria 2 says that candidate B should then be declared the winner. But if we vote by plurality, candidate B is not declared the winner. So criterion 2 is not satisfied. And the plurality method is unfair under that criterion. All right, so now let's look at criterion 3. So criterion 3 was kind of convoluted. Suppose that candidate X is declared the winner of an election. So in our case, remember, candidate A was chosen to be the winner by plurality, and then a second election is held. If some voters rank, in our case, A, higher in the second election than in the first election without changing the order of the other candidates, then A should still win the election. So if we go to our table, the idea here is that A in this new election will still retain all the first place votes that they got before. So these voters just leave their rankings as is. But if A can move up without changing the order of B and C, then this criterion says A should still move the election. So you can move A to the top in either of those rows, and all that's going to do is give A more first place votes, which is still going to get them the plurality win because they have at least 5 votes, and it's not going to change how many votes B or C gets. So A would still win the election in that case. So criterion 3 is satisfied. So lastly, let's talk about criterion 4. Okay, so criterion 4 says, suppose that candidate X is declared the winner of an election and then a second election is held. If voters do not change their preferences, but one or more of the losing candidates drops out, then candidate X should also win the second election. So here we're talking about candidate A. So what we want to think about for that one is, all right, so A wins by plurality. So now let's say a loser drops out. So let's pretend that candidate C drops out. but the order doesn't change for the other candidates. Well, now in the second election, B wins column 2 still going to get that 4 votes, but B is ranked higher than A here, so B is going to get these additional 2 votes. So now B wins in the second election, which is not what criterion 4 says should happen. It says that A should still win the election. So criterion 4 is not satisfied, and this voting method is not fair under this criterion. Okay, we're going to get a little more practice here evaluating a specific election and the 4 criterion, or under the 4 fairness criteria. So we want to see who wins by single runoff in this election. And again, it's a 3-candidate election. So single runoff is where you take the top 2 and you eliminate the last place. In this case. So let's see how many votes each candidate got. So I'll start with A. A is 13, and that's it. B is 11, and that's it. And then C is 14. And so now in a single runoff, we would eliminate the last place, or we would eliminate all but the top 2. In this case, that means the last place. So B's out. Rankings stay the same. And then let's recount A and C. So A gets 13 plus 11, which is 24. And C gets 9 plus 5. So C still just gets their original 14. So the winner by single runoff is candidate A. Now, does this violate any of the 4 fairness criteria? So the original election is out of 38 voters, and none of the candidates got more than half of those votes. So criterion 1 being the majority criterion does not apply here because nobody got the majority of the votes in the initial election. So it does not apply. Criterion 2 is pairwise comparisons. So we need to go through and look at our pairwise comparisons. So let's look at A versus B first. So we ignore C. In A versus B, looks like B wins column 1, A wins column 2, A wins column 3, and B wins column 4. So it's 18 to 20, and B wins that one. Let's look at A versus C. So column 1, C wins. Column 2, A wins. Column 3, C wins. Column 4, A wins. So that's going to be 14 for C, 24 for A. A wins that one. And then B versus C. Column 1, C wins. Column 2, C wins. Column 3, C wins. Column 4, B wins. So that's going to be 27 to 11, and C wins that one. Oops. So nobody wins all of their matches. So criterion 2 also does not apply. Criterion 3. So criterion 3 is the weird one. It's the monotonicity criterion, where if a candidate is declared the winner, then a second election is held and some voters rank that winning candidate higher without changing the order of the others, then that candidate should still win the second election. But that's actually not the case in this example. So I'll show you why. If we look specifically at the third column, let's say that these people moved A up to first place, so that A then gets those the votes from that column. Remember, A is our overall winner by single runoff. Let's see how that impacts the first round of the election. So now we have A, B, and C. So if everything else remains the same, that's going to give A 18 votes in the first round. Notice that C is only now the winner in column 1, so C gets 9, and B gets 11. So that creates a situation where the runoff is now between B and A. And so now we're going in and ignoring C in all the other columns. Well, A wins columns 2 and 3. So A just stays at 18 because B wins columns 1 and 4. So B ends up with 20 votes, and that changes the outcome of the overall single runoff election. In that case, candidate B would end up winning, which violates criterion 3. Okay, last one. Let's check on criterion 4. So criterion 4, again, is the one that tells us that if there is a second election and one of the losers drops out, then our candidate A should still win the second election. And this is called the irrelevant alternatives criterion. Well, we already know from what happened in the original election that if we drop out candidate C, then candidate A still wins. So it's not violated in that case. But if the other loser drops out instead, so we hold the original election, and then candidate C drops out, then you have an A versus B scenario again. And B winning columns 1 and 4 gives them 20 votes to A's 18, and that would change the outcome of the election. Candidate B would win again. Criterion 4 says that shouldn't happen. The original candidate should be winning if it's a fair election, so criterion 4 is violated as well. All right, let's analyze one more election here. So another preference schedule. Here are the outcomes for candidates A, B, and C. See how many votes they get by plurality. Does this satisfy the 4 criterion? So A got 10, B got 4, and C got 2. So A is the winner. Criterion 1 is the majority criterion, which says that if anybody wins the majority of the votes, they should be the overall winner. And A has the majority of those votes, 10 out of the 16 votes, and A is the winner, so it is satisfied. All right, criterion 2. This is our pairwise comparison, so let's look at our pairwise comparisons here. We'll start with A versus B. Column 1, A wins. Column 2, B wins. Column 3, B wins. But overall, A got 10 to B's 6, so A wins. Let's look at A versus C. Column 1, A wins. Column 2, C wins. Column 3, C wins. But it's still 10 votes for A to 6 votes for C, so A wins both of their matches. We can stop there. It doesn't matter what happens B versus C because A already won all of their pairwise comparisons. And A also wins the election by plurality. So criterion 2 is satisfied. Criterion 3. Again, this is the one if some of the other voters, so what we would say is if in columns 2 or 3, these voters changed the position of A to a higher position, A should still win the election, and that is the case here. So criterion 3 is satisfied. Criterion 4, if a loser drops out and another election is held, then A should still win. And we saw by pairwise comparisons that that was the case regardless of who dropped out, right? So meaning if C dropped out, then it would just be A versus B. And we saw that A wins. And if B drops out, then it would just be A versus C. We saw that A wins. So criterion 4 is also satisfied. And this is deemed a fair election by satisfying all 4 fairness criteria at the same time. All right, let's talk about Arrow's impossibility theorem and what that means. So it's basically this. No voting system can satisfy all 4 fairness criteria in all cases. That doesn't mean it's impossible to have a fair election. I just gave you an example where all 4 were satisfied, and that was fair. It's this in all cases that you need to remember. There can be fair elections, but when you have to analyze it for all possible cases, meaning all possible voting structures and choices of orders for these preference schedules, there is no system of the 5 that we went over, and in fact there is none period that could possibly be invented that can satisfy all 4 of those fairness criteria in all cases. So like the plurality the plurality method will satisfy the majority criterion all the time. It will also satisfy the monotonicity criterion all the time, but it will not satisfy criterion 2, the pairwise comparisons, at all times, and it won't necessarily satisfy criterion 4, the irrelevant alternatives criterion, at all times. So what's the takeaway here? Well, Winston Churchill kind of stated it that no one pretends that democracy is perfect or all wise. Indeed, it has been said that democracy is the worst form of government, except for all those that have been tried from time to time. So his point is, right, it's not perfect, and we don't have a way to make elections perfectly fair by our defined criteria at all times, but it works better than everything else. So there are some alternative voting methods that are interesting, and although no voting system can be perfect, the search for a new method that might give fair results more often than traditional methods. So one kind of system is called approval rating, which asks voters to specify whether they approve or disapprove of each candidate. And so they'll ask you to first give your vote for who you'd prefer, and then list off who you approve and disapprove of. And then the candidate with the most approval votes wins. So let's look at an example of that. So these are the opinions of voters in a particular 3-way election for governor. So 26% want A as their first choice, but would approve of B. 25% want A as their first choice and approve of neither B nor C. 15% want B as their first choice and approve of neither A or C. 18% want C as their first choice, but would also approve of B. And 16% want C as their first choice and approve of neither A or B. So the total is 100%. So we're going to contrast the results if the election is decided by approval voting versus plurality. So let's start with plurality. And that's just who gets the most first place votes. So we have candidates A, B, and C, and this time they're giving us the results in percentages. So A, if you add up their first place votes, they get 51% of the vote. B gets 15%, and C gets 34%. So the winner is candidate A. So now let's look at approval. If a candidate is wanted by a group as their first choice, it's understood that they are also approved of, right? So A, B, and C. So 26% want A as their first choice. All right, so A is approved of here. They're approved of here. They're not approved of here. They're not approved of here, and they're not approved of here. So they retain 51%. All right, so now let's look at B. B, they are approved of in that first bullet point. Not approved of here. Are approved of here because they're wanted as a first choice. Are approved of here, and then not approved of here. So B gets 26 plus 33, which is going to make it 59% approval. And then let's look at C. C are not approved of in the first one, not approved of in the second, not approved of in the third, yes approved of in the last two. So C gets 34% approval. So the winner by approval would be candidate B. The winner by plurality, was candidate A. All right, so it's not always the case that each vote has the same amount of power. Shareholders and corporations generally are given votes in proportion to the number of shares that they own. And when voters form groups or coalitions that agree to vote the same way on a particular issue, the power of individual voters is affected. All right, so a small corporation has 4 shareholders. The 10,000 shares in this corporation are divided among the shareholders as follows. So shareholder A basically owns 26.5% of the company. B owns 25.5% of the company. C holds 25%, and D holds 23% of the company. Now, if we assume that the voting power that they have is proportional to their ownership in the company, and they hold a vote, and shareholder D misses the vote, does it matter? Well, it might seem like it should. Shareholder D owns a pretty large chunk of the company, 23%. But the issue here is that any combination of 2 other voters will form a majority. So B and C make up 50.5%. That's a majority. A and B make up 26.5 plus 25.5, 52%. That's a majority. A and C make up 26.5 plus 25, which is 51.5%, still a majority. Whereas shareholder D would need the sides of 2 others to make up the majority. And without D, those 2 others would already make up the majority anyway, so they don't need D. So no, D has 0 voting power, even though he or she owns 23% of the company. So that's the idea behind voting power. Last thing I'm going to have you do is this student example. This is about voting power of people voting for Senate in a more populous versus a less populous state. So go ahead and pause it here, read through the example, and we will go over this in our next class together.